This half of the presentation is going to look at the physical and chemical properties of the alkanols, and then some practice questions. We're going to begin with physical properties of alkanols and with boiling point. So on the slide you'll see a graph which shows the boiling point of alkanols versus the number of carbon atoms. The alkanols are given by the red line, and you can also see that on the graph we have the boiling points of the alkanes with the same number of carbon atoms given in blue. So what I would like you to do is think about what conclusions can be drawn from this graph about the boiling points of alcohols. I'd like you to come up with 2 points. First of all, a general trend relating to the slope of the red line, and second of all, we might want to think about how alcohols compare with alkanes. Pause the video now and try to answer those questions. Okay, so on this slide you'll be able to see the conclusions that I've come up with. You might have come up with something else. Let me know if you have. What you can see from the graph, first of all, is that the boiling point of the alcohols increases as the number of carbon atoms increases. The other thing that you will notice is that the boiling point of an alcohol is higher than the boiling point of an alkane with the same number of carbon atoms. Make sure that you've written down these 2 key points. Okay, I'd now like you to think back to the hydrocarbon topic and think about what happens when these molecular substances boil. Well, hopefully you remember what happens is that the intermolecular forces between the molecules break. The covalent bonds that are holding each molecule together do not break. It's what we call the intermolecular forces which break, meaning that the molecules become separate in the gas state but do not break down into the individual atoms. So, copy and complete this sentence to explain the trend observed. The sentence says, the boiling point of alkanols increases as the number of carbon atoms increases. This is because the strength of the intermolecular forces between alkanol molecules what? So what do you think it is? Do you think the strength of the intermolecular forces increases or decreases? Pause the video now and copy and complete the sentence. So what you should have said is that the boiling point of alkanols increases as the number of carbon atoms increases. This is because the strength of the intermolecular forces between alkanol molecules increases. If the forces holding the molecules together are stronger, then they're going to require more energy to break, so the boiling point will be higher. I'd now like you to think about the correct option for this sentence. The alcohols have higher boiling points than the corresponding alkane. This is because the alcohols have stronger intermolecular forces or covalent bonds. So pick the correct answer from those 2 and copy the sentence down. Okay, so what you should have said is that the alcohols have stronger intermolecular forces. Remember, it's the intermolecular forces that break when these substances boil, not the covalent bonds. So it's the strength of the intermolecular forces that's important. We're now going to look at the solubility of alkanols, which is another of their physical properties. The graph shows the solubility of alkanols in water versus the number of carbon atoms. What I'd like you to do is think about the 2 questions on this slide. What conclusion can be drawn from the graph, and why do you think ethanol is not on the graph? Pause the video now and try and answer those questions. Here are the answers to the questions on the previous slide. The solubility of the alkanols decreases as the number of carbon atoms increases. This is a really important fact to remember as it comes up a lot in exams. Make sure you write this down. Why do you think ethanol is not on the graph? Well, you might have suggested that the solubility value would be too high. We'd have to have a different scale because ethanol is really, we would say, fully soluble in water. I'd now like you to take a note of the chemical properties of the alkanols. The main chemical property of the alkanols is that they are highly flammable and they burn with a clean flame, meaning little soot is produced. On the slide there you've got a good example of this. So ethanol can be used to flambe dishes in cookery and no bad taste is left. There's no soot or unburned carbon left once the ethanol is burned. This is our final slide which shows some of the uses of alkanols. So Alcohols, as I said at the beginning of the topic, are used in many products that we can find around our home, many everyday consumer products. Ethanol, obviously alcoholic drinks, is one of the products, but it can also be used as a fuel for vehicles. This is particularly common in Brazil. And ethanol can also be used as a solvent for varnish, perfume and deodorant. Methanol is mixed with ethanol to make methylated spirits, so that's a fuel that you can buy for camping, and they put methanol in it to make it poisonous so people don't drink the ethanol. Methanol is also used as a fuel on its own and as a feedstock for making chemicals. Propanol is a third member of the alkanols. It's used in medicine, it can be used in hand sanitizers and drug preparation, also again used as a fuel in its own right and again as a feedstock for making chemicals. You don't necessarily need to copy down this whole slide, but make sure you've written down at least 3 different uses of alkanols and that you learn them, because again this is something that comes up very often in exams. We've now finished covering the mandatory knowledge about alcohols at National 5 level. Please take a moment to read through the success criteria on this slide. In the next few slides, we're going to look at some practice multiple choice questions which will check that you've got the hang of the basics when it comes to alcohols. Question 1. Which of the following reactions takes place when an alcohol is formed from an alkene? A. Hydrogenation, B. Combustion, C. Hydration, or D. Reduction? Pause the video now and answer that question. The answer to question 1 is C. Hydration. So remember, when alkenes undergo addition of water, so it's an addition reaction, but addition of water, that is specifically called hydration, and this is the reaction that forms alcohols from alkenes. Question 2. You're given a structure, as shown on the slide, and it says the systematic name for the above compound is A. Pentan-2-ol, B. Pentan-4-ol, C. 1-methylbutan-3-ol, or D. 4-methylbutan-2-ol. Pause the video now and try and answer that question. The answer to question 2 is A. Pentan-2-ol. Remember, when naming alkanols, that you need to number the carbon atoms from the end starting closest to the hydroxyl group. So the carbon on the furthest left of the structure is going to be carbon number 1, meaning the hydroxyl group is on number 2. You might have been mistaken into thinking that the carbon at the bottom right of the structure is a branch and gone for C or D, but if you look closely you will see that that carbon is just a continuation of the main chain. You can follow with a pencil or your finger, you can follow the carbon atoms round and there's no break in the chain. So the hydroxyl group is on carbon number 2 and there are 5 carbons in the main chain, so it is pentan-2-ol. Question 3. Which of the following alcohols is the least soluble in water? A. Butan-1-ol, B. Hexan-1-ol, D. Pentan-1-ol, or D. Propan-1-ol? Pause the video now and answer the question. The answer to question 3 is B. Hexan-1-ol. Remember, the solubility of the alkanols decreases as the number of carbon atoms increases, so the one that is least soluble will be the one with most carbon atoms. butanol has 4 carbon atoms, pentanol 5, and propanol 3. Hexanol has 6 carbon atoms, so it will be the least soluble. Finally, I'm going to leave you with a little challenge to find some alcohols in your home. Alcoholic drinks don't count, and you certainly shouldn't be drinking them. Look at some of the bottles of products in your home. Moisturisers, shampoos, perfumes, deodorants and cleaning products are a good place to start. See if you can spot alcohols in these products. You will recognise them from the "all" ending to the name. Thank you for listening to this video.